Again, we can step up our ability to solve equations, and based on what we have already at our disposal with solving equations that have only one variable and no crazy powers, or solving equations that can be factored, we have a way of being able to at least introduce this idea for the time being without complicating matters anymore. We can take all this business with these rational expressions and throw these into the equation mix. Basically what we would want to do, because the issue here, like we've seen in certain other kinds of equations in the past, is that we don't like the way that fractions look. We don't like the extra complication that they create for us. So if we've got an equation with denominators showing up, we'll go ahead and we'll follow the same sort of plan of attack as we've said in the past, even though these denominators have variables in them rather than just being numbers. We don't like the fractions. Let's wipe out those denominators and see how things pan out. So we're going to use the common denominator, or officially speaking, we kind of push towards the least common denominator. And because we can have those variables showing up, maybe you want to make a quick comment about anything that makes that common denominator 0, because those numbers are not going to be allowed as solutions. Now, if you want to do so, great. If not, you're still going to be encouraged, and you would be wasting an opportunity to refuse this. Check your answers. And if you check your answers, you'll catch that same sort of issue as well. So, using that common denominator, doing some multiplication work, what we can do is, and you see it starting to peek up here at the bottom of the screen, we can wipe out the appearance of all of the denominators so that what we would achieve is an equation that has a much more familiar and comfortable sort of appearance to it. And in this particular case, we end up with nothing too awfully crazy. We've got just a nice little linear equation that we can work through and solve. We end up getting w equals 2. So whatever polynomial shows up there, if we can solve it directly like this, great. If we need to use our factoring skills to solve it, also acceptable, though more of a time commitment. As always, when we solve equations, let's not waste the opportunity. Let's check our answer. Now, in this particular case, I glossed right over it. I have made the comment in the first step that we cannot have w equals -2 or w equals +2 as an answer. If we actually check the w equals 2, we can see why that's the case. Literally, when you take the 2 and put it into that second denominator and third denominator, those two denominators turn into zeros, and that's a no-no. So whether we get it by checking in step 4 or having made a note of things in step 1, there is that possibility that we might have to throw out one or more answers, because this is the only answer that we have arrived at, and it does not work. Then there is no other solution. This particular equation overall has no solution. So yet again, we can see that sort of possibility happen no matter what kind of equation we might be confronted with. But again, what we want to do is emphasize the process here and make sure that you can get comfortable with the ideas of what's happening. So if we take a look at another example and work this one out together, what we are doing here at first is starting with factoring any of the denominators that need to be factored so that we can pick out a least common denominator to use for our first step. So if we take that second denominator, x squared plus x minus 6, and factor that, we'll have an x minus 2 and an x plus 3. So we can go ahead and, off to the side, write down a comment here about that LCD. The first denominator that we see is an x minus 2. In the second denominator, we already see an x minus 2, so we're good to go as far as that, but we also have an x plus 3 showing up in that second denominator. So let's include that in our LCD as well. The third denominator does not have anything else extra. We've already got the x minus 2 written down there as part of our LCD. So we've written the least number of factors that will allow us to eventually get rid of the first, the second, and the third denominator. So let's go ahead and do that. But let's also be a little bit more conscientious about our own time and trouble. The gist is that we would want to take each fraction that shows up and multiply it by that LCD. So let's go ahead and do that right away. This is again coming from multiplying on the left and right sides by that LCD, but we're just trying to get more quickly to the heart of the matter. So let's go ahead and get more quickly to the heart of the matter by doing just that. Multiply each fraction by that LCD. So, get out the red pen so we can start marking things up. From that first fraction, we've got an x minus 2 on the bottom, we've got an x minus 2 written in blue. Those can get slashed out by. In that second fraction, we have an x minus 2 on the bottom and an x minus 2 in blue. We've got an x plus 3 on the bottom, we've got an x plus 3 in blue. We can slash out both of those by. Swear I'm not singing in sync. In the third fraction over on the right hand side of our equal sign, we got an x minus 2 on the bottom, we've got an x minus 2 written in blue. We can go ahead and slash those out by. And then let's write down what we have left. Back to the front, we've got a 6 followed by that blue x plus 3 still showing up. From that second fraction, after our minus sign, we've slashed out everything except for the 20x that shows up there. Over on the right-hand side, we have the x from the numerator as well as the blue x plus 3. So now this is the equation that we would want to solve. We would want to start by trying to simplify the appearance of things. And when we start to do that, over here on the right side, we notice that what we get would be an x squared. So hopefully once we actually notice that that is appearing, we would think to ourselves, we need to get everything over to one side of the equal sign and a 0 on the other side. So in this particular case, it's just a lot more direct for us to get the 0 on the left side of the equal sign. Let's go ahead and get rid of the 6x, get rid of the plus 18, get rid of the minus 20x, and combine like terms along the way. That means that we would be looking at having the x squared. We have a plus 3x. We would minus 6x and also plus 20x. So overall, that would give us a plus 17x. We would want to minus the 18, since that does not have any other like terms to worry about. Minus the 18. And now we're in a position where we can factor. So if we factor, we would get an x plus 18 and an x minus 1 equals 0. We switch sides on the equal 0. Excuse me. That means that we've got an x plus 18 equals 0, or and x minus 1 equals 0, giving us two possible solutions, x equals negative 18, or x equals 1. If we take the time and trouble to check this out, now let's try to squeeze that original problem up there at the top again. If we take that x equals negative 18 and slap that in, that's a 6 over negative 20. Let's actually write it out. Let's be a little bit more conscientious about the work that we're doing here rather than skipping steps and inviting in errors. Taking that negative 18 and putting it in the second fraction. We are taking it all the way back to the top equation, the one that was originally given to us. So notice that I'm not using that factor denominator there. If I go through all the time and trouble of checking that out, I should find that that works a little bit quicker for us to handle. The x equals 1. Still that same idea of plugging in the 1 into our original equation. And seeing if our equation does in fact match up and we should find that that also checks out, giving us two solutions in this particular case. X equals negative 18 and x equals 1. Again, let me try to emphasize here the steps that we've got, starting with the first step at the top of the screen. The same way as in the past, if we have fractions, we said let's go ahead and clear those fractions out if we multiply by the LCD. We figured out our LCD. We took our first fraction times the LCD, second fraction times the LCD, third fraction times the LCD, and that allows us to wipe out all of those denominators and get at least a somewhat friendlier looking equation to work with. Using our skills from solving equations, we recognize that we've got a quadratic equation. We only have factoring at our disposal to try to solve that, meaning that we need to have an equal 0 before we can try to factor. So we get the equal 0 on the left-hand side. We factor the x squared plus 17x minus 18. Set each factor equal to 0, giving us our two possible solutions that we take advantage of our wonderful opportunity and check for ourselves to make sure that they work in order to be much more confident that we have the correct solutions. But beyond this, these types of equations show up in a few different useful ways, and some of those ways we've seen in the past. One of them we will talk a little bit more about briefly. So other ways that we have rational expressions and therefore rational equations popping up. We could have a proportion. A ratio is equal to another version of that same ratio. So the cute little dentist commercial, 4 out of 5 dentists prefer Dentine, 4 out of 5. Now if I go out and I talk to a total of 248 dentists that chew Dentine, how many total dentists do I talk to? Well, dentists that chew Dentine shows up on top of my ratio. The total number of dentists shows up on the bottom. I don't know what that number is for the total survey, but I have a way of being able now to work that out using ratios and proportions. Without fancy gadgetry, I can use the idea of similar triangles to do things like the old school way of finding the height of a tree based on the shadow of the tree versus the shadow of a person whose height is known. So if I'm hiking along and my wife is 5'6" and I measure her shadow, and then I measure the tree's shadow, I can figure out how tall that tree is. Because I've created similar triangles between the height of the tree and its shadow, and the height of my wife and her shadow. And by creating those kinds of ratios, again, we would have rational expressions, and in an equation, that means we'd have rational equations, and we could work out the height of a tree. Then we also have problems that involve rate. Literally, how fast can a person do a job? Or literally, how fast can a person walk or drive or bike or fly? So things that involve rates are also automatically related to ratios, which are related to rational expressions, which might show up in equations, therefore rational equations. In this particular case here with the paper route, 3 hours for one kid to do it, 4 hours for another kid to do it when they work individually. But what happens if they work together? Well, part of the job is done by one kid, part of the job is done by another kid. They work the same amount of time, and while they do a little bit different amount of work, all together they have to do one job total. What we get is an equation that has fractions showing up, has rational expressions showing up. And one of the cute things from way back in the day, especially for those older students or those inclined towards nostalgia, there is the baseball movie Little Big League, where a kid of a grade school, middle school age somehow or another manages to become the manager of a baseball team, and amidst preparing for a game, he also has to worry about math homework. If you Google Little Big League math problem, you'll find a cute little clip of all of these baseball players and the kid arguing about how we're supposed to work out how Joe can paint a house and Sam can paint a house, and if they work together, how long will it take them? And here's the proposed answer, and you can verify through a similar sort of setup as to this example whether that proposed answer is in fact correct.